Hi there. Go ahead and open up your notes to lesson 4-2A, where we're going to be looking at patterns and linear functions. Our goal is to be able to represent functions using tables, equations, and graphs. We're going to see if we can write a linear function to represent a relationship. All a function is just a rule. Okay, the linear relationships we're going to be looking at make a straight line, just like the first four letters in the word linear. Let's give this a try. So here's our first scenario. You're going to see that we have the relationship between kites and how many ribbons that they have up here on the screen. We're going to take this information, put it into a vertical table, graph it to see how it's linear, and then write an equation or a function rule to represent the situation. All right, so let's give this a try. Okay, so we're going to take the information that's up here and just put it in a vertical table, because I think that sometimes when you make a vertical table, it's a little bit easier to write a function rule. So just like you see here, this is going to be our x, our kites, and our y is going to be our ribbons. X is, it's kind of like if I make a table like this, do you guys see how that's kind of horizontal right there? So we've got one kite, two kites, three kites, and four kites. Our X is going up 1, 2, 3, and 4. And then the number of ribbons is going to depend on how many kites we have. So when I have one kite, I have 5 ribbons, and you're probably already seeing a pattern. 2 kites, there are 10 ribbons. 3 kites, there are 15. And 4, there are 20. Okay, so now just by looking at these numbers here, you probably could figure out if you had, I don't know, like 50 kites, you probably could figure out how many ribbons just by looking at this pattern. Okay, so let's give this a try. We're going to graph this relationship. So our x-axis, of course, is down here. X is across, and y goes up and down. And then we'll just graph these kind of like ordered pairs. So imagine if this was an ordered pair, x comma y. So we're going to go over one kite, up 5 ribbons, over 2 kites, up 10 ribbons, 3 kites, up 15, and 4 kites, up 20 ribbons. And you're going to see that if you were actually to connect the points, it would make a straight line, which is what's making it linear. Linear makes a straight line. There's a linear relationship between the number of kites and the ribbons. As one goes up, the other one goes up at a constant rate. So then what we want to do is write an equation. We want to be able to write a function rule where we could use this rule to figure out the number of ribbons for any number of kites. So you think about back from when you guys were in like 6th and 7th grade, and when you were looking at input values and output values. Your input was your x and the output is your y. So if I were to plug like a 1 into this function machine and it pops out a 5, what's it doing? If I were to plug a 2 into the function machine and it pops out a 10, what's happening in here? If I plug a 3 in, what's happening to pop out a 15? Of course, it's multiplying by 5. Okay, that's the rule. So how do I write that? Well, I'm going to start with y equals. So to get y, to get any number y, what do I do to x? What's happening to x to get y? What's happening to x to get y? What would have to happen to x here to get y? Well, you'd have to take x and multiply it by 5. We always write our number first, and I don't need to have a dot. So to get y, I would take 5 times x. This is just as simple as looking straight across the table and seeing what you multiply by, something that you have done before. Very simple, okay? So that is our rule, our equation. Our graph is linear, and our table shows a linear relationship also. Let's take a look at another one here. In this case, with the table I'm about to show you, it's not that easy to write a linear function rule because you can't always just look across from x to y. So take a look at this table right here. It looks like you're multiplying by 3, but is that consistent? Is it multiplying by 3 anywhere else? No. Even if you look at this and think, am I adding 4? Nope, that's not consistent at all. Okay, so what it means is that it's a combination of multiplication and addition. So you may try and figure out, well, what do I multiply the x by and then add? Well, could you figure out what would I multiply this 4 by, and what could I add to get 7? What would I multiply 6 by? What could I add to get 8? Now you could sit and think about it all day long, but there's a quick, easy way to do this. And so I'm going to give you this trick. So to figure out the number that you multiply by, it's your y over x pattern. So you look at the y and you figure out how much is it going up by. Pick any 2 points. So it's going up by 1. And then look at your y. What's it going up by? It's going up by 2. So the y over x pattern, this ratio of y over x would be 1 over 2. 1 over 2 is a half. That is your multiplier. Okay, that's how you find that first number that you multiply by. But of course, you're not done yet, because if I take this 4, this x value, and multiply it by half, that's only 2. What do I then need to add to get 7? Try it with a 6. If I multiply it by half, that's 3. What do I then need to add to get 8? If I take 8 and multiply it by half, that's 4. What do I then need to add? Are you seeing that in every single case, you're going to need to add 5 to get across after you multiply by half. So that becomes our function rule. To get across from x to y, I multiply the x by half, and then I add 5. So this is a quick trick to come up with your rule when it's a combination of multiplication and addition, and it's not just multiply. Okay, so let's look at a couple examples where that happens. So here we've got weight in ounces of something that we're purchasing and the cost. So again, just like a regular table, x always comes before y. We got x and we got y, and this is just a horizontal table. We're just going to change it to write it vertically because sometimes it's easier to make to write an equation. So it looks like 2 ounces is $12, $12, and then I've got 4, 16, 8, 24, and then 10, 28. Okay, so let's go ahead and graph. Remember, the x was the ounces and the y is the cost. Okay, the cost depends on how many ounces I buy. All right, so let's go ahead and just graph this. So if I buy 2 ounces, it's going to cost me $12. That would be about right here. 4 ounces, 16, 8 ounces, 24, and 10 ounces, which would be about here, it would be about 28. So that would be right about here. So if you look at the points from the 4 numbers in the data set and you connect them, they make a straight line. Now I also want you to notice that here when I buy 0 ounces, it's going to cost me $8. Well, that must mean that I bought something else. So maybe I bought milk and eggs, and that was $8. Then every time I buy ounces of strawberries, the cost is going to go up. Okay, so this is just what I purchased right here before I bought any strawberries. Let's just say that's strawberries, okay? All right, so we have a linear relationship. Okay, so that means that we want to, now what we're going to do is come up with an equation. Now take a look. Is it just straight multiplication? Do I just multiply across? Well, it looks like times 6. Take x and times it by 6, but that doesn't work here and it doesn't work here. So it's not just multiply, it's a combination of multiply and add. So maybe you can just look at it and figure out, what do I multiply this by and then add? What can I multiply this by and then add the same number? What would that be? You could guess and check all day long if you want to. But I'm going to show you again that quick trick that will always, always work. To find the multiplier, the number we multiply by, we just look at for the y over x pattern. So what is it going up by in the y? It looks like we're going up by 4. And what are we going up by in the x? We're going up by 2. Kind of hard to see. So the ratio of y over x would be 4 over 2, which simplifies to 2. That's your multiplier. So boop, I'm going to put it right over here. We're multiplying by 2, but it's not just multiply by 2. I then have to add something. So if I take this and multiply it by 2, that would give me 4. What do I need to add? If I take this number and multiply it by 2, that would give me 8. What do I then need to add? If I take this and multiply it by 2, I get 16. What do I need to add? Yeah, you seeing it? You need to add 8. So this becomes your rule. So if I was buying, 100 ounces of strawberries, I could use my rule and figure out what it's going to cost for 100 ounces of strawberries. It would be $208. Okay, so that's that quick trick to come up with your equation or your rule, especially when it's not easy to look straight across. Okay, let's look at the next one. Here we have no situation whatsoever. It's just a list of ordered pairs. Now you guys know with ordered pairs, this is x, y, x, y, x, y, x, and y. So our goal here is to write an equation for how do we get from x to y. It's much easier to do this if you have it in a table. So let's organize this in a table. 0, 2, 4, 4, 8, 6. I'm just taking these points and I'm putting them in my table. My last one's 12, 8, 12, 8. Now let's go ahead and graph, and we're going to see how this is going to be linear. All of these are going to be linear. Okay, so 0, 2, 0, you don't go over, but I go up 2, over 4, up 4, over 8, up 6, and over 12, up 8. And we're going to see how this is perfectly straight, makes a straight line, it's linear. Okay, that means that the function rule is going to look like this. Well, check first. Is it just simply multiplying straight across? No, we're not multiplying by a constant number straight across. If we were, that would be easy. So that means it's a combination of both. You could guess and check and figure out what you multiply by and then what you add, as long as it works for everyone. But a much quicker strategy is to use my trick. Look for the y over x pattern. That will always be your multiplier. So let's go. Y, it's going up by 2. X, it's going up by 4. That's going to be consistent. Same thing here. This is going up by 2. This is going up by 4. It's always going to be consistent. You just have to pick 2 points. So that looks like the y over x pattern is 2 over 4, which simplifies to a half. That's your multiplier. So I don't just multiply by a half. I then have to add something or maybe subtract something. So here, if I multiply this by half, I get 2. What do I need to add then? See? If I multiply this by half, I get 4. What do I need to add? If I multiply this by half, I get 6. What do I need to add? Do you see how you're adding 2 every single time then? So my rule would be multiply x by half and then add 2. So to get from any x value to y, I take x multiplied by half, which is 6, and then add 2. That's going to be my rule. So if I had any other numbers here, like let's say I had the number 100 and I wanted you to tell me the output value, you'd take the x, which is 100, multiply by half, which is 50, and add 2, and you'd have 52. That rule is going to work for anything on your table. All right, here, last one before I have you try this. So this is going to look a lot like one that you're going to do in your practice today. We're representing the relationship between the number of triangles and the perimeter they form. Perimeter is the rim around the outside when you add up the side lengths. Okay, so imagine this is a triangular table. And if I put 2 triangular tables together, I could find the perimeter here. So let's first start off by taking this information and organizing it in a table, because it's going to be much easier to write an equation or a function with. So the x value is going to be the number of triangles. Here's 1 triangle, then 2 triangles, then 3 triangles, and 4. Okay, the perimeter is the y value. That's our dependent variable you'll learn later. The perimeter is going to depend on the number of tables. It's what we're measuring. So I want to find the perimeter when there's just 1 triangular table. That means I add the sides. 3 plus 4 plus 3, which will give me 10. Okay, and then when I have 2 triangular tables put together, 3 plus 4 plus 3 plus 4, you add the perimeter there, that's going to be 14. So then here, when I've got 3 triangular tables put together, 4 plus 4 plus 3 plus 4 plus 3, I'm going all the way around the outside. The perimeter here is going to be 18. I can already start to see a pattern. It looks like every time I add a table, I'm adding on 4 to my perimeter. Let's check this one. 4 plus 4, 4 plus 4, 3 plus 3. That is true. I get 22. Okay, so that's perimeter, distance all the way around the outside. So every time we add a triangular table, we get an additional 4 in our perimeter. So I'm going to put down 100 triangular tables. We're going to figure this out later once we come up with our rule. So let's graph. We're going to see how this is a relationship that's linear. So 1 triangular table, I have a perimeter of 10, 2 triangular tables up 14, 3 triangular tables up 18, 4 triangular tables, perimeter of 22, and I can see that that is perfectly straight, which is a linear relationship. It makes a straight line, which means we can easily write a function rule. Okay, so is it just multiplying straight across? Is it just multiply by 10? Oh, that's not consistent. Nope, it's not just multiplying by numbers straight across. That'd be too easy. It's going to be a combination of both. So how do I figure that out? Well, you could play guess and check, or you could use this y over x pattern to come up with your multiplier first. So if I do that, it looks like the y is increasing by 4 and the x is going up by 1. 4 over 1 is 4. So that's my multiplier. I know I'm multiplying by 4, but it's not just multiplying by 4. I have to add something then. So here, if I take this x value and multiply it by 4, I get 4. What do I need to add? If I take this and multiply it by 4, I get 8. What do I need to add? If I take this and multiply it by 4, I get 12. What do I need to add? I'm hoping that you're seeing that you add 6 in all cases. Okay, so now if I had 100 triangular tables, 100 is my x, I'd take 100 times 4 and add 6. So I would have 406 as my perimeter. So this rule can get me any perimeter for any number of X tables. Okay, so now you're going to be seeing in your notes that you have 4 tables right here. And what I want you to do is to write the function rule. How do I get from X to Y? Okay, now it could just be simply multiplying straight across. What do you multiply by? Or it could be a combination of multiply and adding or subtracting something. So maybe you want to start off by just writing these blank boxes here, y equals box x plus box for each one of them. And then you can take a look and see, all right, how do I get from X to Y? What is the rule? And remember that quick trick, you can always find the Y over X pattern. So right now I want you to pause the video, see if you can come up with the function rules, and then push play and check your answers. Go ahead and pause now. All right, are you back? Let's check your answers. We're going to see how you did. Now, down here at the bottom, this one was pretty easy because your X is here, your X, and then your Y. And if you look across from X to Y, it's just a simple multiplication. You're literally multiplying this X by 10 times 10 times 10 times 10. So there's nothing to add or subtract. So it's just Y equals 10 times X. That's your equation. That's it. Okay. This one was also pretty easy. You could just look across and you could see, well, it's dividing by 2. So what's that the same as multiplying by? Absolutely. Dividing by 2 is the same thing as multiplying by half. You're really taking 1/2 times x. It's just as simple as multiplying by half. Now, if you didn't know that, you could figure out your y over x pattern. Remember, that's your multiplier. The y is going up by 2 and the x is going up by 4. So 2 over 4 simplifies to 1/2. Okay? Now, these other two are a little bit trickier. Let's look down here at this one right here. Now, it looks like I could multiply by 2, but then this is multiplying by 3, and that's not constant. So it's a combination of both. So to find this multiplier, I'm going to go y over x. Y, this is increasing by 12, and x over here, this is increasing by 3. So 12 over 3 would be 4. That's my multiplier. So I'm multiplying by 4, but then I have to add something or subtract something. So if I take this number and multiply it by 4, take the x multiplied by 4, I get 12. Well, I'm going to have to subtract to get 6. I'm going to have to minus 6, aren't I? So here, let's see if this is the same. If I take this x value multiplied by 4, I get 24. I'd have to subtract 6 to get across. Here, if I take this 9, this x, and multiply by 4, I get 36. I'd have to subtract 6 to get across. So this is really to get y, I take 4 times x, but then I have to minus 6. So either one of these are correct. Plus negative 6 or minus 6 is probably better to write like this, though. Okay, and then this last one, I can't just multiply straight across. This is times 4, and this is not times 4. So I'm going to use my quick trick. I'm going to find the y over x pattern. Y looks like it's going down 3, and the x is going up 1. So that's negative 3 over 1, which simplifies to negative 3. That's my multiplier. So then what do I need to add? So if I take this x value and multiply it by negative 3, I get negative 6. What would I then need to add to get 1? Yeah, 7. Does that work here? If I take 3 and multiply it by negative 3, I get negative 9. Could I then add 7 and get me across? Absolutely. So this is the rule for this table. So hopefully it went okay for you. Thank you for joining me for lesson 4.2. We're just going to do a quick summary, and then I think you guys are going to be ready to go on your own. So let's quick summarize. The graph of a linear function always makes a straight line. Yes, because linear has the word line in it. Now, let's quick summarize. How do you write a function rule? There were 2 different ways that we did this. So I'm just going to draw a line straight right here. And then on the left, the first way that we did this was just looking across. If we look across from x to y. So sometimes we can literally just look straight across in a table and figure out exactly what we multiply by. That's super easy. Now, if that doesn't work, then we got to use that trick. And remember that trick is y equals box x plus box. This could be either plus or it could be minus. It depends. I just kind of write plus as a generic, okay? Now, when I do this, I have to find the multiplier first, and that's my y over x pattern. And once I find my y over x pattern here, then I know what I multiply by. That is just as simple as looking across to see what do I still need to add or subtract to get across the table. Okay, if you need to pause the video to go ahead and copy down that summary, go ahead, and then good luck on your practice today. And again, thank you for joining me for lesson 4 too.